So thank you all for joining our presentation on New York City MapViewer and exploring ways to responsibly make these maps that we've included in Population MapViewer. We're really excited to be part of Open Data Week, but also to show you this preview of our latest iteration of our app. We've added new maps that we're adding to Population MapViewer, and it should go live in the next week or so. Just to kind of give you an idea of what you'll see in the demonstration of the new maps, we've refreshed with the latest ACS data, and we've also added a host of new maps showing counts for detailed race and ethnic groups from the 2020 census. Charles will walk you through how all of this information looks in the app. And how to navigate it. And you can follow along in the live version if you want to understand the functionality, but it will look a little different than what we will be showing you on the screen. And then before diving into the demonstration, I'll tell you a little bit about the challenges we face when we're trying to map, what we do behind the scenes to address these challenges, and what you should be aware of if you're trying to make similar maps. Before I dive in, if you want to use the reactions emojis, have any of you used Population MapViewer or even our other application, Population Fact Finder, ACS, decennial data, anything that is part of this? Just give a thumbs up or something to that sort. Okay. So to start with, what is Population MapViewer? It's an interactive website that allows you to explore characteristics across neighborhoods in maps and rank charts. You can also view changes across time and examine neighborhoods vis-a-vis other neighborhoods and the city overall. So if you're familiar with our other application, Population Fact Finder, in there we use thematic maps to help guide your selection. But here we were able to take it a step further and allow you to really explore these characteristics. However, if you want to still use a full profile of the data, that you'll have to go back to Population Fact Finder or our website in order to get that data. So in Population MapViewer, we have two sources of data that the maps are using. We have the decennial census and the American Community Survey, or I'll refer to it as the ACS. Hopefully, most of you have worked with these data. So what I will go through in the next couple slides will just be a quick refresher. The decennial census, shown here on the left in our black and white map, is a full count of the population of basic demographic and housing characteristics. These are characteristics like total population, age, sex, race, ethnicity, tenure, and occupancy. The census has always been the gold standard when it comes to population data. And for the 2020 census, the data were released in parts. The latest data includes population counts by detailed race and ethnicity. And this release was a big deal, still is a big deal. It's the first time that the census included write-in responses for the white and black racial categories. And so now we have 2020 population counts for groups such as Italian, Polish, African-American, Jamaican, as well as Dominican, Puerto Rican, Chinese, Bangladeshi, and Guyanese. And looking at all of these groups and the data for these groups, it really illustrates the great diversity of New York City. And so while these data are based on the full count of the population, the Census Bureau must protect the privacy of all participants. So there's a bit of an asterisk to these race and ethnicity data, especially when mapping, which I'll touch on a bit later. So here on the right, our second source, the ACS, it's shown as a fuzzy but colorful map, and that's because it's a survey that's sent to approximately 3.5 million US addresses every year, about 2 to 3% of all addresses in the country. This provides an accurate and reliable portrayal of national and state, even the city and borough populations. However, because of sampling error, accuracy and reliability are diminished, which is why we've shown the map as fuzzy. In order to have a large enough sample to create estimates for the census tracts, the ACS rolls up the sample over 5-year periods. And even the 5-year period estimates do not produce reliable results for all areas. So it's important to assess the reliability for estimates. It's also important to keep in mind that whereas the census data is for a point in time, April 1st, 2020, the ACS estimates are for a period and span 1 or 5 years, depending on the data set you're working with. So what you're really talking about is that midpoint of that period. Okay, so geographies. We have 3 geographies that we frequently work with below the borough level. We have the census tract here on the left, neighborhood tabulation areas or NTAs or neighborhoods, and then community district tabulation areas or CDTAs on the right. So while census tracts are fine-grained, they are a small ACS sample size, which makes the data with the census tracts less reliable. On the other end of the spectrum of the sizes, we have the CDTAs, and they're much more reliable, but the larger area precludes detailed demographic analyses. So in the middle of these two are the NTAs, which is that balance of the reliable data, but more geographic specificity. And so this is the geographic level that we use to map our characteristics in Population MapViewer. And we have more information about each of these geographies on our website in this link on the bottom of the screen, which you can get to from our website, but it's the Atlas of New York City 2020 Census Statistical Geographies. So as I've mentioned, the ACS data are from a sample. So there's a margin of error associated with these data. I won't get too far into the weeds here, but just take a look at these margins of error, the blue bar, the thin bar. They're exactly the same margin of error, but in relative sense, the NTA's margin of error is much smaller, and that's called relative reliability or coefficient of variation or CV. This is the relative reliability, and it's important to gauge with this whether or not the data are good enough for general use. And so while there's no hard and fast rule, the Population Division has endorsed a CV threshold of 20%, where estimates with CVs of 20% or more are considered too unreliable for most uses. And this is what we've used in Population Fact Finder, where all of our estimates with CVs of 20% or more, the data are grayed out. So if you're familiar there, you would have noticed that there. So just a quick visual of this. Here you can see 2 maps for the population living below poverty. On the left, we have unreliable census tracts, and on the right, unreliable NTAs. The census tract map is almost entirely lit up. Individual census tract data here are just too erratic. But when you go up to the neighborhood level, the data are just much more reliable. So the big takeaway that you can get from this, without understanding the whole depth of CVs, is that when confronted with unreliable ACS estimates, there's 2 primary methods of improving reliability: aggregating across geography, so building up from tracts to NTAs, or you can combine characteristics, so combining age categories or, for example, or the number of vehicles available, another variable that can be collapsed. But both of these methods help increase sample size and reduce sampling error. When we map out our ACS data, these reliability issues don't just vanish. They're still there, and it's important for you to take into account. So we've developed this map reliability calculator. Also, it's on our website under resources. And this is a quick and easy way to check the data, to check if the data you're mapping and the map breaks you're using pass the reliability test. We've used this behind the scenes on all of our ACS maps in Population MapViewer. And while the unreliable NTAs are not grayed out the same way that they are in Population Fact Finder, it's important to consider margins of error of individual NTAs when you make reference to the data in your work. Another thing we did in the background in preparation for MapViewer was a test or an analysis on a series of commonly used ACS variables across the spectrum, including median age in demographic, less than high school diploma in social, unemployment in economic, and vacant housing units in housing. And we wanted to test the mappability and how many classes you could use across these variables at the census tract and at the NTA level. And that really solidified our decision for NTAs, but you'll see what we found. So here, this is by census tract, and you can see that you really can't map these variables at the census tract level. So with the 2011 to 2015 ACS data shown in the red, 42% of the variables we evaluated could not be reliably mapped. And it's just gotten worse with the 2017 to 21 ACS data. There's been a decrease in sample size and an increase in the margins of error with the more recent data. And so it's not surprising that the mappability also has taken a hit. Of the other 35% of variables that can be reliably mapped, you can see that you can really only get 2 classes. And binary maps in some cases is all you need, but you really miss out on the detail that you're after at the census tract level. So moving up to the NTA level, things looked a lot better. While we still took a hit between the 2 periods, at the NTA level, only 12% of the variables could not be reliably mapped. But just look at the detail that you can get at this level of geography. 40% of variables can be mapped using 4 classes, even 32% using 5 classes. So being able to use 3, 4, 5 classes makes for a much better map that can reliably tell the story and distinguish between NTAs and classes. And lastly, before we move into the demonstration portion, I mentioned earlier that there's a bit of an asterisk in mapping 2020 census data. All 2020 census data, including the detailed race and ethnicity data, are affected by the Census Bureau's infusion of noise for privacy protection, and thus comes with a band of uncertainty. Another way that the Census Bureau incorporated privacy protection is that all geographies and for every given detailed race and ethnicity group, the Census Bureau suppressed data of small counts. All of that includes noise. And so when the geographies are aggregated, such as going from census tracts to neighborhood tabulation areas or NTAs, there can be compounded error from both suppression and intentional noise infusion. All of that can be found, more details can be found in our About page on Population MapViewer, and also the Census Bureau's technical documentation for the latest data release. Okay, so I'll stop there on the background information. I'm happy to answer questions after Charles's demonstration on any of this, but I want to give him time to show off the application. That's what we're here for. Quickly before I do, Population MapViewer is on our website. The easiest location currently is on our homepage, on the Population Division homepage, in this middle section down at the bottom. It can also be found in resources up at the top. And with that, I will hand it over to Charles. You want to share your screen now?
Yes. All right. Thank you so much, Erica. And thank you so much to all of you for being here today. My name is Charles Christonikos. I'm now going to give the live demonstration of Population MapViewer, going over its different layout and features and show you how it can be useful for your work and for data users in general. So let me just share my screen and we'll get rolling. Okay. You can see that fine? Awesome. All right. So like Erica mentioned, Population MapViewer is in essence a collection of interactive maps that allow you to explore the diverse demographic landscape of New York City's neighborhoods. And when you open the link to the website, you'll see this interface, and the default map will show a total population map. Each map page in MapViewer is organized like this map you see here, with a map on the right, a chart on the left, and various other features that I'll explain in a bit. So Population MapViewer currently features 47 key variables from the 2020 census and latest American Community Survey for you to explore. And the way we have these different variables and pages organized is under these drop-down menus here. These first 2 drop-down menus contain maps based on variables from the 2020 census. Here under Demographics 2020 are more basic overall demographic variables such as total population, population density, age, race, ethnicity, and housing variables. And this next section here called Detailed Race and Ethnicity is actually not yet live. And this contains all of our maps of detailed race groups. These next 3 categories here correspond to 3 main American community subcategories. So under social, we have maps of educational attainment, place of birth, and English language proficiency. Under economic, we've got 2 maps, one of median household income and one of the population below poverty. And lastly, under housing, maps pertaining to median gross rent, rent burden, and the prevalence of overcrowding in New York City. So to talk now a little bit more about like what you're actually seeing here and what's included, this map on the right shows New York City divided into neighborhood tabulation areas, which, as Erica mentioned, is the geography we've chosen for MapViewer because they're large enough to show finer grained detail than you could see at a larger geography, but they're also large enough to minimize issues of error and reliability. And just so you know, I'll be interchanging the term NTA and neighborhood from here on in. So each neighborhood tabulation area or neighborhood in the map is color coded according to the class of values that it falls into. And what these classes are is explained in this legend in the top corner. So for example, in this map, neighborhoods in this darkest red-brown color have populations of 90,000 people or more, whereas those that are in white have total populations less than 30,000. These are obviously really big ranges. So if you want to get the exact figure for a particular neighborhood, all you have to do is click on it in the map. So right now my cursor is over Jackson Heights in Queens. And if I want to know the exact population in 2020 of this neighborhood, all I have to do is click on it. So I clicked on Jackson Heights and I can now see that the population in 2020 of this neighborhood was about 102,000 people. You'll also notice that when I clicked on that neighborhood in the map, a line became visible in this chart. What this chart is doing is it's rank ordering all of the neighborhoods from greatest to least for the variable you're looking at. So just looking at where Jackson Heights' line lit up, you can see it's one of the most populous neighborhoods in New York City. Conversely, you can select a neighborhood directly from the chart, and you can hover over each line to see which neighborhood it corresponds to. And when you do, its location will become highlighted in the map. And you can even hold down and drag to select multiple neighborhoods at once. Oh, and another useful feature of this chart is this line going down the middle. This is showing you the average for New York City. So in this case, this line is now telling me that the average total population of a neighborhood in New York City is about 45,000 people. And just at a glance, you can really easily see which neighborhoods fall above this average and which fall below. So with these two features alone, the map and the chart, you begin to see the utility that MapViewer has as a powerful analysis tool. Because not only are you getting the spatial context of the variable you're looking at from the map, but you also get the ordinal context for your particular area of interest. So say you're looking at the neighborhood that you live in, you can easily see how it compares to the city as a whole and to other neighborhoods. Another good thing about MapViewer is some of our variables, you can view them in their temporal context. So in other words, how they've changed over time. So for example, here in the bottom right corner, we have this button that says change. If I click on it, I'll now be brought to a version of the total population map that is showing me how much each neighborhood's population changed from 2010 to 2020. You can see the color scheme is a bit different. Here, blues indicate increases, reds indicate decreases, and the darker the blue or the red, the bigger the increase or decrease. And what stands out to me here is that almost every neighborhood is blue, which means that almost every neighborhood's population grew over the decade, and therefore New York City's population grew overall over the past decade. But you do see a couple of exceptions. So for example, there's this whole part of Upper Manhattan here that are all showing decreases. If I want to investigate further and see which neighborhoods these correspond to, all I have to do is scroll in on the map onto that location. And you'll notice that as you go closer into the map, the labels of the different neighborhoods become visible. Also, another way to zoom in and out is by using these plus and minus buttons here. So now that I'm this close, I can see that this area that saw decreases over the decade corresponds to Washington Heights, North and South, as well as Inwood. And if I were to zoom in a little bit further, eventually the layer will become semi-transparent and you can see the underlying street network. This is really useful if you're trying to find a location and you just know like an intersection or just to see the different boundaries of these geographies that we have for neighborhoods. And by the way, another way to find a particular location is this magnifying glass icon here. You just type in an address or a place, and the application will bring you right to that location. So I'm just going to like zoom and pan around the city and look at what the chart is doing on the left. It keeps updating in real time. Earlier, I mentioned that the chart is rank ordering neighborhoods from greatest to least, but it's only doing so for the neighborhoods that are currently in view in the map on the right. So let's say I hid everything except Staten Island. This chart is now only rank ordering Staten Island neighborhoods from greatest to least. And this is really useful if you want to like hone in on a particular part of the city and see how neighborhoods that are close to one another compare to one another. And to return to the default citywide view, all you have to do is click on this home icon here. Spending a little bit more time in this map, the areas that saw the biggest increases in total population over the decade tend to be in this general part of the city, Lower Manhattan and along the East River in Brooklyn and Queens. These are neighborhoods like Long Island City, Hunters Point, Williamsburg, downtown Brooklyn, Dumbo, Boerum Hill, etc. These are all neighborhoods that saw large-scale rezonings over the past few mayoral administrations, and therefore, over the past decade, this is where the most new housing went up. But there is one key limitation of this change map and the other change maps that we have here available, because back when I was on this count map, I did mention that, these neighborhoods all have differing base populations. Some neighborhoods have over 100,000 people, whereas some have as little as 15,000. So that means that in this map, say you had two neighborhoods that both saw an increase of 10,000 people, but one had a starting population of 5,000, the other one started at 100,000, they would both show up as having the same change in this map, but the intensity of the change between those two cases is obviously much different. So to account for that, we've also included percent change versions of our change maps. This is instead showing you change as a percent, and it's using that original base population in 2010 as a base. And this has the effect of normalizing all the different base populations, and you can compare the intensity of change between different neighborhoods in relative terms instead. So now looking at the same part of Lower Manhattan I was just looking at, the same kinds of neighborhoods are showing up. But looking at this chart now, you see that there's one neighborhood that grew in relative terms by leaps and bounds above all the other ones. And that neighborhood was, drumroll, Long Island City, Hunters Point, which grew by nearly 200%, which is massive. Basically, the population here tripled over the past decade. And if you're a planner at New York City Planning, we're planners. I'm not a Queens planner, but if I was and I was responsible for this area, I would see this observation. It might, encourage me to ask, okay, we have all these new people and housing units here, but are things like schools and services and infrastructure keeping up, looking forward to 2030 and beyond? So this is a really good example of how looking at a variable in its temporal context really gives you a better understanding of what's going on. So another way of looking at total population is in terms of population density. New York City is, it's one of the most densely populated places on Earth, certainly in the United States. And what this map here is showing you is the population density in New York City per acre. The average line in the chart will tell you that the citywide average is 46 people per acre. But here you see a pretty clear geographic pattern. Areas that are more in the core of the city, so basically all of Manhattan and a big part of the Bronx, et cetera, have the highest densities. This is where people are more likely to live, closer together in larger apartment buildings. But then looking at more peripheral areas like Eastern and Southern Queens, as well as all of Staten Island, these tend to be less dense. People tend to live in smaller housing units farther from each other. So that's a pretty clear pattern that you can see pretty clearly in the map, I think, but you don't really get a sense of that in this chart. A limitation, that I acknowledged is that you have to scroll over each of these lines to see which neighborhood this is. So to account for that, just want to let you know that you can view the same chart in an alternate version in each of the maps by clicking on this link that says View Detailed Chart. You'll see a separate window come up like this. This is the same underlying chart, but it's static. It's not changing in real time as you zoom in around the city like the other one. And another added bonus here is that you actually see the neighborhood labels as well as a borough abbreviation here. So looking at which borough abbreviations show up a lot here at the top, it's basically all Manhattan and Bronx, like I pointed out. And then at the very bottom, a whole lot of Queens and Staten Island. So I just wanted to point that out. Most of our maps, however, they deal with more specific populations. So for example, here under demographics, we have maps of the four main race ethnicity groups: Asian non-Hispanic, Black non-Hispanic, Hispanic, and white non-Hispanic. And I'd like to show you our Hispanic map. So I've already shown you, the default versions of the maps, which are count, as well as change and percent change. But some of our maps also have a fourth option to view, which is as a percent. The difference between count and percent is pretty similar to that between change and percent change, because whereas in this case, the count map is showing me the aggregate number of Hispanic people living in each neighborhood, the percent map would instead show me the Hispanic population as a proportion of the total population. And this helps answer, a different question than the count map. The count map answers the more quantitative question, where do the most Hispanic people live? The percent one will answer a more qualitative question, which neighborhoods are Hispanic neighborhoods? Where is that like a key characteristic of the population? So just looking at, the default count map, you see Hispanic presence throughout all 5 boroughs. But then switching to percent, you get a more specific understanding of this population spatiality. You see where it's more concentrated and where it's more dispersed. So now you see like basically the entirety of the Bronx has lights up because the Bronx is the majority Hispanic borough. Also Upper Manhattan, this general area of Queens around like Jackson Heights, Corona, Elmhurst, along the Brooklyn-Queens border, Sunset Park, North Shore of Staten Island. So I just wanted to use as an example to show you how viewing something as a count versus a percent gives you a more nuanced understanding of characteristics relative to other groups. Other maps that we have in this section here are our maps pertaining to age. So I'd like to show you our map of median age in New York City. Median age is a pretty useful snapshot of the age composition of a given area. So in New York City overall, the median age is 37 years old, which means half the population of New York City is below 37 and half is above. And you can see in the map, you see a pattern as well, where more peripheral areas tend to have higher median ages, whereas those closer to the core tend to have lower ones. And median age is really useful at a glance, helping you understand, does the population skew older or younger? Is it working age? Is it aging, etc. But there's only so much it can tell you, because imagine you had one neighborhood where everyone is where half the people are 25 years old and the other half is 75 years old. Median age is going to be 50. But then you have another neighborhood where everyone is 50 years old. Median age will also be 50. But these are obviously two completely different age profiles that have different planning priorities and other things. So because there's so much to be gleaned from understanding age composition in a given area, we've included a special advanced feature for this map only, which you can access by clicking this button at the very bottom, which says age charts. And when you do, you'll see another separate window come up. And it has the same underlying map, but now each neighborhood has an interactive graphic on top of it. This is an age pyramid. And what it's showing you is the percentage of the neighborhood's population within each 5-year age bracket. So looking at the farthest end here, this is the percentage of this neighborhood's population between the ages of 0 to 5. Next is between the ages of 5 to 9, all the way up through 80 to 84 and 85 plus. And this is really useful because you can see where are there spikes, where are there dips, and this allows you to really easily compare different compositions between different neighborhoods. And I'd like to spend a couple more minutes explaining here what kind of information you can glean by honing in on the borough of the Bronx, which is my home borough. So let me just go up there and zoom in. Okay, so in the Bronx, you see some pretty interesting contrasts. There's this one neighborhood here in the entire borough over here. It's called Belmont, where the median age is below 30. It's the lowest in the Bronx. And it looks to be that this is because there's a spike here and people aged 15 to 19 and 20 to 24. Would anyone like to guess in the chat what might be going on here? Erica, let me know if anyone gets it.
College, a university.
Yes, correct. This is the location of
college. Everyone's getting it. It's great.
Okay, cool. Yeah, Fordham University. It's a pretty big university, and that's why you see this big spike in people who are college age. And you see that reflected in the entire neighborhood. But the more general pattern that you see in the Bronx, particularly in the South Bronx, is median ages between 30 and 35 years old. And looking at the charts here, the more general pattern is like a higher and more consistent proportion of early all the way through middle ages. So looking here, you see like pretty consistent proportions of children, adolescents, young adults, but once you get past like 40, 45 or so, percentages begin to decline. And once you're at the very farthest reaches, the population is negligible. Contrast that though with a place like Co-op City up here in the Northeast Bronx. This neighborhood has the highest median age of any neighborhood in the Bronx at 50.6 years old. And you'll notice what looks to be a spike in people generally between 50 and 70 years old. This is because people who live in Co-op City tend to be of the same generation. Either they or their parents moved there back in like around the 70s when the co-ops were being built. So you can very clearly see this group aging as a whole. And lastly, you have a place like Riverdale Spite and Dival, which is actually where I live. And here you see this also has a high median age, about 45 years old, but you see more of a rectangle here. Pretty consistent proportions throughout, even including 85 plus. 5.1% of this neighborhood's population is 85 or more, which is highly unusual. You very rarely see that. Like I said, I live here, so I know why this might be. We have a lot of like nursing homes and assisted living facilities, so we do have a higher overall senior population, and you're seeing that reflected here. So this is one of my favorite features on MapViewer, and I urge you to spend some time looking at your own neighborhood and others. There's really a lot of fascinating stuff to glean from here. Switching gears just a little bit, I'd now like to show you a preview of some of our maps in the detailed race ethnicity section. This is the newest addition we've made to MapViewer, and this should be going live in the next week or so. So you guys are the first to see this. So earlier I showed you the overall Hispanic map in the previous section, which is just showing you the major race groups overall. But these are instead showing you detailed individual subgroups. If you remember from filling out the 2020 census, you had the option to write in a detailed race for all race groups. And prior to 2020, only Hispanic and Asian respondents had that option. So this is the first time we've had this kind of detailed information, particularly for the white and black subgroups, and a much greater understanding of diversity in New York City. So what you see here is 15 maps of major detailed groups in New York City, as well as 5 key regional groups organized by race and ethnicity. Looking, for example, at the map of the Italian population, Italian is a major white subgroup in New York City. Before I dive into what the map's actually showing you, just want to point out that the data behind all of these maps in this section, the count maps, they are representing everyone who identified either solely with that group alone or in combination with other groups. So just to say that here you're seeing both people who said they report being Italian alone or Italian in combination with something else. And looking at the percent version of this map, you see the borough that has the highest concentration of Italian population is Staten Island. Looking down here, all of these neighborhoods on the south shore of Staten Island have an Italian population that's a third or more. And the neighborhood with the highest percentage, Tottenville, Charleston, has a 45% Italian population. Within the Hispanic population, though, Dominicans are the largest detailed group, and Dominicans are actually the largest detailed group in New York City overall. Here, you also see the presence throughout all 5 boroughs, but looking at the percent map, you see the Bronx and Upper Manhattan light up, particularly this area around the Harlem River. All of these neighborhoods have a population that's at least a third Dominican, with the highest one being Inwood at nearly 50% Dominican. Within Black subgroups, Jamaicans are a major group. Unlike the 2 groups that I just showed you, which are like pretty widely dispersed throughout the city, this population is more concentrated in 3 distinct areas of New York City. So like East Brooklyn and Southern Queens. These are areas where you'll also see other Black Caribbean subgroups like Haitians really represented. But what makes the Jamaican population really unique is this area up in the North Bronx near like Woodlawn, Wakefield, Eastchester. So just interesting to see the unique presence of Jamaicans in that part of the city. And lastly, under Asian, we have our map of the Chinese population. Another huge group that's present throughout all 5 boroughs. Looking at the percent version of this, historically, you may know that historically the Chinese population was concentrated in Lower Manhattan, particularly around Chinatown. And the detailed chart actually does tell you that Chinatown remains to this day the neighborhood that's the highest percentage Chinese, over 60%. But you might also know, living in New York City, that there are other Chinatowns. So particularly around Flushing in Queens, and also down here in South Brooklyn around Sunset Park and Bensonhurst. So, there's so much to be gleaned from this, and be on the lookout for when we actually release these. There's all these other groups to explore. And yeah, we're really excited about this section. So trying to wrap up a little bit here, I'm now going to show you some of our ACS maps. These are largely organized similar to the ones I've shown you before, but there are some important differences to keep in mind when interpreting and communicating data from the ACS. So for example, what I'm showing you right now is the map of the limited English proficiency population. These are people who report speaking English less than very well. So this has useful implications for like understanding where language services are most needed. you'll notice that instead of count, it's called estimate because the American Community Survey is a survey. It's based on a sample. It's not based on a detailed count like in the census. And with estimates come margins of error. So for example, if I want to know the LEP population in Jackson Heights, click on Jackson Heights, I see an estimated LEP population of about 37,000 people, as well as a margin of error of plus or minus 2,700. The way to interpret this is that, in the real world, the number of LEP speakers in Jackson Heights is either this many more than the estimate or this many less. It's somewhere within that range. And in the detailed charts, you will actually see this margin of error range illustrated visually with these upper and lower bounds. So just to keep that in mind. And this is a map of the overall LEP population, but I just want to point out that we have two more specific maps of the Chinese LEP and Spanish LEP population. These are showing the same information, but specifically for those who speak either of those languages at home. And the last map that I want to show you here is my absolute favorite. This is our map of the foreign-born population. And I think this map is really cool because I think it underscores just how New York continues to be defined by its diversity, and how New York City continues to serve the unique role of being the main point of entry for new immigrants to the United States, with today's JFK Airport playing the same role that Ellis Island did a century ago. And like looking at the percent version, Queens is renowned around the world as like probably the most diverse urban setting on Earth. And you really see that in this map. Almost every neighborhood in Queens has a foreign-born population of 35% or more. Up here, these have 50 or 60%, and that's not even accounting for second or third generation immigrants. So really cool. I love this map. And there's so many more here for you to explore, but for the sake of time, I have to start wrapping up now. But there are a couple other features that I haven't gotten into that I would like to point out. So for example, each of these pages has this print widget here. If you want to export any of these maps in like a nicely formatted PDF format, you can simply just select a page size and orientation, click print, and you'll see something similar to this if you want to like export it or share it somewhere. Each page that you have here also has a unique URL. So if I were to copy and paste this URL, put it in like a hyperlink or an email or a report somewhere, I'd be brought right back to this foreign-born as percent of total population map. Also down here, these data boxes have a link to download data. So when you click on that, you'll be brought to our website to download an Excel table of the data behind these maps. Also up here in the header, we have a link to Population Fact Finder. Also this About section, which has basically just more detailed information about what I've gone over today and the different data sources behind here. And lastly, I've shown you this on a desktop, but if you were to open this website on your phone or your tablet, you would see this, which is the mobile-friendly version of MapViewer. It has much of the same functionality, the different versions, the legend, the pop-ups, and even here, view detailed chart, you can see how neighborhoods rank against each other on the go. So yeah. Oh, one last feature is up here, we have this envelope icon, which has our MapViewer DL email. We want to add more features in the future, more maps and more functionality, but ultimately we want to hear from you, the users of it. So if you have any questions or concerns, feedback of any kind, or you want to let us know what you'd like to see here, please do send us a message here, and we'd really appreciate it. Also, I didn't get into much detail about how we actually created this feature, this website. It was created using Esri Products, ArcGIS Online, and Experience Builder, as well as Tableau. If these are things you have access to and would like some guidance on how to use, I'm glad to give you my contact information and help you out with that. So with that, we've reached the end of the demonstration. Thank you all for being here, and I'll take any questions in the time remaining.
My question is around connecting some dots. So you have you've added the detail, race and ethnicity portion component to the maps. I'm wondering if your department has done any analysis to try to understand the economic implications, housing implications as it relates to these races.
So I could take that, Charles. We haven't dug too far into these data from the detailed race ethnicity section yet and the individual groups. For a past analysis that we're currently working to update, we have the newest New Yorkers on our website. It's our, big book that's available. It should be updated and released, I think, the beginning of next year at this point. And that's where we take a look at detailed groups and, larger characteristics beyond just the individual counts. We also have a few story maps on our website that look into different topics, but beyond these maps, there's not really a connection to extra characteristics through these maps themselves. You can make assumptions, but nothing that connects the maps. But you can see our website for all the material that we have up there.
Yes, Missy?
Thanks. And I'll say, I think there's a bunch of questions in the chat for maybe some people who don't want to I go on camera, but mine is just kind of like a quick feature question. So thank you for walking through all of this. In terms of selecting multiple neighborhoods, is it possible to do that through clicking on the map rather than kind of highlighting in the chart on the side?
Yeah, that's a good question. Unfortunately, no, it's just a limitation of the software. You can select multiple from the chart, but for some reason, it only allows you to select one at a time from the map itself.
Okay, thanks.
And Charles, I'll address a few questions that are in the chat. I'm trying to scroll through, so if I miss your question, I'm very sorry. But there's a question about Filipino being separated from Southeast Asian, and I can quickly address that. These categories are based on the Census Bureau's data and how they're released. You can see the Census Bureau's documentation that we will be posting in our About page, and it'll have more explanation on each of these. But Southeast Asian is a regional group. They've separated groups into regional and detailed groups. Southeast Asian is regional. Filipino nests within regional. We did not make these groups. It's based on the Census Bureau's definition. So please read more about them there. And then there's another question on exporting these maps. Charles, if you want to answer that.
Right. Are we able to export the maps as a DWG or any CAD shape files? Directly from the website, no. All that really is available here to export would be the actual tabular data itself by clicking on the download data links and going to our website. However, a lot of these geographies are available on Bytes of the Big Apple. They are available on open source data like that. The neighborhood tabulation areas are a geography on Bytes of the Big Apple, right, Erica?
Yes.
Yeah. So yeah, that's what I would refer to if you'd like the shape files.
And then there's a question about seeing population differences in the time periods. So the data that we've included here are the two decennial census time periods that you're seeing change for. And so that's April 1st, 2010 to April 1st, 2020. So the question from the census as it comes is, where were you on April 1st? And that's where you get counted. Unfortunately, it's not a pick and choose your date for the data that's in this application. It's just based on the census data that is available. And then in terms of, I guess we don't have change for the ACS, but the ACS period that we will be updating the data for this next release is the 18 to 22 ACS 5-year period. So that's looking at that one data set. It's the 5-year period. So it's not a change over that 5-year period. It's the data for that period, if that's more confusing. There's also information on the American Community Survey that can be found on the Census Bureau's website, but also on our About page on MapViewer and on Population Fact Finder.
And I'm seeing a recent message. Would you mind repeating what you used to build this? Yeah. So the actual web maps that you see here, they're created in ArcGIS Online. But the actual website overall is a separate Esri service called Experience Builder, which basically is like a software to build like a website like this. And the main plugin would be the ArcGIS web maps. And some of the other features that you saw, like the detailed charts, those were made in Tableau and like embedded separately. But yeah, those are the three main programs that we use to make this.
Okay, there's another question about the Filipino and Southeast Asian maps. So in building Population MapViewer, we have to be somewhat initially selective in building this app. This app is powering a lot behind the scenes, and we wanted to start with top or largest groups and then continue to build out from there as we hear groups that people are interested in seeing and diving further into. All of the data for groups are going to be available on Population Fact Finder in data form, and they're also all available on the Census Bureau's website. These are select maps. These don't cover all the groups, and they also don't cover all the variables in the ACS or the census. So this is just a picking for now of a couple maps. And this is, we haven't even launched these maps yet, so this is truly just the preview. We will continue adding additional in the future. And in cleaning and aggregating the data, we pull the data from the Census Bureau site. For the most part, we've aggregated the data in Excel. It's very simple, but we have also used outside programs for other times and data sets as well, R specifically.